Hello friends, Diane here. I'm so happy to see you again. Today, we're going to be talking about using arrays to understand multiplication. I was at the home improvement store yesterday looking at tiles to use in my kitchen, and it made me think about some of our math problems. Some of the tiles come in arrangements of equal rows and columns. In mathematics, this is called an array, and it's used as a strategy for multiplication. Before we continue with our lesson today, let's use a Frayer model to help us understand a little bit more about arrays. To make our Frayer model, you will need a piece of paper and a pen, a pencil, or a marker. I'm going to get my supplies. You go ahead and do the same. Now that we have our supplies, let's begin to make our Frayer model. Let's take a piece of paper and fold it in half, hamburger style. Then we are going to fold it in half again. Finally, we are going to use this corner where all the sides are folded. We're going to make a small triangle. When you unfold the paper, it should look like this. Does yours look like mine? Okay, great. We are going to write array in the center diamond because this is the word we need to understand more about. Then, in the upper left rectangle, we're going to define this term. So let's write the word definition here. In the upper right triangle, we're going to provide an example of arrays. So let's write example here. And then, in the lower left rectangle, we'll provide a non-example, or what arrays are not. So write non-example here. Finally, in the lower right rectangle, we'll draw a picture to help us visualize what arrays are. So let's write the word picture here to remind us of what we're supposed to do. Now, we're going to define the word array together. So let's write the definition in our upper left rectangle. An array is an arrangement of items into equal rows and columns. We can use arrays to help us represent and solve multiplication and division problems. As we learn more about arrays in today's lesson, you'll be able to add examples, non-examples, and draw a picture to share your growing understanding of equal groups. Now, let's get back to the home improvement store where I was looking at some tile designs. Let me show you how one tile design looked. Could you sketch this on your paper and then count how many tiles are in this design? many did you count? Right, there are 8. Now, how did you count them? Okay, some of you counted by 4s. Right, very nice. I'm going to write the number 4 at the top of this note. How many tiles are in each row? Then, some of you counted by 2s. 2, 4, 6, 8. I'm going to write the number 2 to the left to show how many rows there are. Remember, this arrangement of equal rows and columns is called an array. We can represent this array with a multiplication equation. 2 times 4 equals 8. I like this design, but what if I decided that I wanted to turn it around? You do this on your paper. The question now is, did the number of tiles change? No. How do you know? Oh, very nice. The array is still arranged in the same number of groups. We didn't add any tiles. We also didn't take any tiles away. This time, there are 4 rows. And we have 2 in each row. We can represent this as 4 times 2 equals 8. Did changing the arrangement of the tiles change the total? No, it sure didn't. So, does the order of the factors in our multiplication equation change the answer or the product? Remember, the factors are the number of groups and numbers in each group, and the product is the total. I hear some of us are not sure yet. Let's try another one and see what we find out. Now, take a look at this arrangement. If you would, draw it on your paper and count how many tiles there are in all. Would you whisper what you got to me? Right, there's 15. This time, how did you count these tiles? Some of you counted by 5s, 5, 10, 15. So we'll write 5 at the top to show how many are in each row. Then some of you counted by 3s, 3, 6, 9, 12, 15. I'll write 3 to the left to show how many rows. So now, what's the multiplication equation for this array? Right, 3 times 5. If I changed the order of the factors, 3 and 5, would the total number of tiles or the product change? Let's see how that would look. You go ahead and turn your paper. Now, the question is, did we take any tiles away? Or did we add any tiles? No. So how many tiles are there altogether? Exactly, 15. The arrangement of the tiles doesn't change the total, and the order of the factors doesn't change the product. Let's try this one. There are 4 rows and 6 in each row. You draw it and count the number of tiles. How many tiles did you get? 24? Very nice. So if you know that a 4 by 6 array has 24 tiles, how many tiles would be in a 6 by 4 array? That's right, exactly, 24. So what if we didn't show the array? What if I said 7 times 5? The 7s are hard for me to memorize, but I know that switching the order of the factors will give me the same answer. And I know my 5s. So 5 times 7 equals 5, 10, 15, 20, 25, 30, 35. So 7 times 5 equals 35. That makes learning my facts so much easier since I know that I can switch the order of the factors and the answer will be the same. So let's do some practice. 5 times 4 equals exactly 20. So 4 times 5 equals 20. What about 2 times 9? Exactly, that equals 18. So 9 times 2 equals 18. 4 times 3, say it with me, 12. So 3 times 4, also 12. Awesome job, mathematicians. Thanks for helping me think more about how multiplication and arrays are related. The number of rows and columns are represented by the factors in a multiplication equation. I learned that changing the arrangement of the tiles doesn't change the total number of tiles. So changing the order of the factors in a multiplication equation doesn't change the total or product. Great job. I think this will really help me learn my multiplication facts. I can't wait to do more math with you. Until next time, bye y'all.